Our solar system feels familiar, doesn't it? We know the sun, that brilliant star at the center. We know the 8 planets that dance around it, from rocky Mercury to the gas giant Jupiter. We have sent probes and rovers to explore their surfaces and atmospheres. We have mapped their orbits with incredible precision. For centuries, we have looked up at the night sky and felt a sense of order, a celestial neighborhood that we understand. But what if that understanding is incomplete? What if there is something else out there, something vast and unseen, lurking in the cold, dark frontier of our own cosmic backyard? This is one of the most exciting questions in modern astronomy. Imagine standing at the very edge of our solar system, far beyond the orbit of Neptune. The sun would be just a particularly bright star, its warmth barely reaching you. Here in this deep, silent emptiness, a colossal world might be tracing a slow, lonely path, a planet so distant that it has evaded our telescopes for all of human history. This isn't science fiction. It is a genuine scientific possibility, a hypothesis that has captured the minds of astronomers around the globe. The idea that our solar system may harbor a 9th major planet, a true giant, is a tantalizing mystery waiting to be solved. It challenges our map of the heavens and reminds us that there is always more to discover. The story of Planet 9 begins with gravity. It is the invisible force that orchestrates the cosmic ballet of the planets. We see it in the moon's orbit around the Earth, and in the Earth's journey around the sun. Isaac Newton gave us the mathematical laws to describe this force, and Albert Einstein refined them with his theory of general relativity. These laws are the bedrock of planetary science. They allow us to predict the movements of planets with breathtaking accuracy. So when we see something that doesn't quite fit our predictions, it's a big deal. In 2016, 2 astronomers from Caltech, Mike Brown and Konstantin Batygin, announced they had found compelling evidence for just such a ghost in the machine. They weren't looking for a new planet. They were studying the strange orbits of a handful of trans-Neptunian objects, or TNOs. These are the small frozen worlds that exist in the dark expanse beyond Neptune. Brown and Batygin noticed the strange clustering of their orbits and calculated the odds of it happening by chance. The number was incredibly small, something like 1 in 15,000. It was far more likely that a hidden object was responsible, its gravity gently nudging these TNOs into their bizarre, aligned paths over billions of years. This unseen object was not just any small rock. Their calculations suggested it had to be enormous. To have such a profound effect on orbits so far away, it would need to have a mass of about 5 to 10 times that of the Earth. This would make it a super-Earth or a mini-Neptune, a type of planet we see often around other stars but don't have in our own solar system. They named their theoretical world Planet 9. So, what exactly is this mysterious Planet 9? Based on the gravitational clues it has left behind, astronomers have been able to sketch a portrait of this phantom world. It is not a small, icy dwarf like Pluto. Instead, the calculations point to something much, much bigger. Planet 9 is believed to be a true giant, a world with a mass somewhere between 5 and 10 times that of our own Earth. This places it in a fascinating category of planet that we haven't seen up close before. At least not in our own solar system. It would be what astronomers call a super-Earth, or perhaps a mini-Neptune. Imagine a world 10 times more massive than our own. Its gravitational pull would be immense, creating crushing pressures deep within its core. What would it be made of? It is unlikely to be a rocky planet like Earth or Mars. A world of that size, forming in the cold outer reaches of the solar system, would probably have held onto a thick, dense atmosphere of hydrogen and helium, much like a smaller version of Neptune. Beneath these swirling gases, there might be a deep layer of exotic ices, not just water ice, but frozen methane and ammonia, compressed under unimaginable conditions. The temperature on this world would be unimaginably cold. Being so far from the sun, it would receive very little light or warmth. Surface temperatures would likely hover around -225 degrees Celsius. However, a planet of this size would likely generate some of its own internal heat, left over from its formation billions of years ago. This faint internal glow might be its only source of warmth, a tiny flicker in the eternal darkness. It is a world that is not just hidden by distance, but shrouded in an extreme cold that makes it profoundly different from anything we know. One of the biggest questions is, Where is this giant world? If it exists, why haven't we seen it? The answer lies in the sheer scale of its proposed orbit. Planet 9 is not just a little bit beyond Neptune. It is thought to be on a vast, looping journey that takes it hundreds of times farther from the Sun than the Earth is. This journey around the Sun could take an astonishingly long time, perhaps somewhere between 10,000 and 20,000 Earth years to complete a single orbit. This immense distance makes Planet 9 incredibly difficult to find. Think about how we see planets. They don't produce their own light. They only reflect the light of the Sun. An object that is 20 times farther away than Neptune would receive 400 times less sunlight. The hunt for Planet 9 is a modern quest, and it requires the most advanced tools humanity has ever built. One of the key instruments in the search for Planet 9 has been the Subaru telescope in Hawaii. These instruments are not designed for the human eye. They use massive mirrors, some many meters across, to collect the faintest whispers of light from the cosmos. This light is then focused onto highly sensitive digital cameras, electronic sensors that can detect objects millions of times fainter than what we can see. The data collected by these telescopes is immense, far too much for any human to analyze by eye. This is where supercomputers come into play. Sophisticated algorithms are designed to sift through these images, looking for the telltale sign of a solar system object movement. The search for Planet 9 is not the first time astronomers have hunted for a world they could not see. The story echoes a remarkable chapter in scientific history from the 19th century, the discovery of Neptune. It all began with Uranus, a planet discovered by William Herschel in 1781. For decades after its discovery, astronomers tracked Uranus's path across the sky, but something was wrong. The planet refused to follow the precise orbit that Newton's laws of gravity predicted. In September 1846, Leverrier sent his prediction to the Berlin Observatory, urging the astronomer Johann Galle to search that exact spot. On the very night he received Leverrier's letter, Galle found it. Within an hour of starting their search, they spotted a faint star that was not on their detailed star charts. The story of Planet 9 is a captivating cliffhanger, a grand cosmic mystery that remains tantalizingly unsolved. The next few years promise to be a pivotal chapter in this story. A new generation of astronomical observatories is coming online, most notably the Vera C. Rubin Observatory in Chile. This facility is a survey machine unlike any other, designed to photograph the entire southern sky every few nights with unprecedented depth and precision. Its vast survey of the cosmos is expected to find millions of new solar system objects. If Planet 9 is out there, and if it is within the region predicted by the models, the Rubin Observatory stands an excellent chance of finding it. The data it will produce will be a treasure trove for planet hunters, and somewhere within that flood of information, the definitive answer may lie in wait. Imagine the day the announcement is made. Imagine news headlines across the globe declaring that we have found it. The discovery of Planet 9 would be a profound moment, not just for science, but for all of humanity. It would instantly and fundamentally change our map of our own home in the universe. School children would have a new planet to learn, and our models of the solar system would all be instantly out of date. The discovery would trigger a cascade of new scientific questions and a frantic rush to learn everything we can about this new world. It would be a moment of pure, unadulterated discovery, a reminder that our cosmic backyard still holds monumental secrets. The discovery of Planet 9 would resonate far beyond just the story of our own solar system. It would solve a major cosmic puzzle: why our solar system looks so different from the thousands of other planetary systems we have discovered in the Milky Way. When we look out at other stars with our powerful telescopes, we find that the most common type of planet seems to be the super-Earth, worlds with a mass somewhere between Earth and Neptune. Yet our own system appeared to be missing one. Finding Planet 9 would not just be about adding another dot to our maps. It would be about expanding our sense of the possible and reigniting our collective imagination. The search for Planet 9 is more than a hunt for a single world. It is a search for a missing piece of ourselves. Whether Planet 9 is found tomorrow, next year, or not at all, the quest itself has already enriched our understanding. It has pushed our technology to its limits, deepened our knowledge of the outer solar system, and ignited the curiosity of millions. The search reminds us that we live in a universe brimming with secrets, that our map of the cosmos is never truly complete. The unending frontier is not just out there in the darkness, it is in our relentless desire to explore it. We have always been explorers, looking just beyond the edge of our maps. From the wobbles of Uranus to the strange dance of the Kuiper Belt, the universe leaves clues for us, and the hunt for Planet 9 is simply the latest, most exciting chapter in our quest to follow them.